I hope you're able to see my screen.
Yes, sir.
Okay. I'll get started. See, we'll be starting with problems which are based on work done by constant force, and we'll see few problems which are based on work done by variable force, and then we'll
Sir,
proceed to the next
now
topic.
it's not visible, sir. Screen.
1 minute. Now I hope it is visible.
Yes, sir.
Yeah. So we'll do problems which are based on work done by constant force and work done by variable force. This itself will give you a clarity on how to handle work done. And this is very, very important because the subsequent topics that we are going to discuss will involve this concept. At that time, you should not have any doubts. So let's see the first few problems. The first one is a gardener pushes a lawn roller through a distance of 20 meter. If he applies a force of 20 kilogram weight, so 20 kilogram weight is how many Newton? I've already told this in the previous chapter. It is 200 Newton. 1 kilogram, write it down. 1 kilogram weight is 9.8 or 10 Newton. You can take it as 9.8 under the scenario when G is 9.8. So in this case, it will be 198 Newton because 20 into 9.8 is going to give you 198 Newton. In the direction inclined at an angle 60 degrees to the ground. Find the work done by him. Okay. So having this question in mind, based on work done by constant force. Okay, what is the first question? So a lawn is being pushed with a force of how much value? 198 Newton at an angle 60 degrees with the ground, and he is able to push through how much distance?
20 meters.
20 meters. Now tell me what is the work done? Work done is F S cos theta. So the force he is applying is 198. S is how much? 20. Cos theta cos.
Sir, 1 Newton is how much kg, sir?
Huh?
1 Newton is how much kg, sir?
1 Newton is?
Voice is little bit feeble, sir.
1 Newton, what are you asking?
Sir, 1 Newton is how much kg, sir? Like, I mean, 1 kg is how much Newton, sir?
Weight is 1 kilogram weight. Kg and Newton cannot be related. 1 kilogram weight is 9.8 Newton.
Okay, sir.
Okay, 198 into 20 into cos 60. That is 198 into 20 into cos 60 is half. It will go 10 times. It will be 19. How much is the answer? 1980 joule. Okay. So this is the answer for the first question.
Sir, one.
Mithun, go a little away from the mic. I think your mic is very close. Your mic is very close. Go.
Sir, I am getting some other answer, sir. Not 198 Newton, sir.
You come 198 only. You go a little away from the mic, no? You go a little away.
Sir, no, sir. 20 into, sir, I'm getting 196, sir.
It will not come to see 198 into 10 is 1980. Okay, 20 into 9.8 is what?
Sir, but 20 to 9.8 is 190.
Okay, 196.
Sir.
Okay, what is that? Okay, 196. into 20. So it should be 1960 then. Go to the next problem. So a person is holding a bucket by applying a force of 10 Newton. He moves a horizontal distance of 5 meter and then climbs a vertical distance of 10 meter. Find the total work done by him. So if you see, there is a bucket and the bucket is held with a force of 10 Newton. He is covering a horizontal distance of 5 meter and a vertical distance of 10 meter. They're asking what is the work done by him. Let's say A to B is horizontal, B to C is vertical. Okay. So what is the work done from A to B? It is F into S into cos theta. Right. The force is 10 Newton. Displacement is 5 meter. Cos of how much?
90 degrees.
9.
So that will be 0. So work done from B to C is how much? 10 into cos.
0 degree.
0.
That's right. 0. That will be 100 joule. So total work done is equal to work done from A to B plus work done from B to C. That is 0 plus 100. That will be 100 joule. Okay. So this will be the required answer. Next problem. So try this. A cyclist comes to skidding stop in 10 meters. Skidding stop in the sense he's applying brakes. Is coming to a skidding stop in 10 meter. During this process, the force on the cycle due to the road is 200 Newton and is directly opposite to the motion. How much work does the road do on the cycle? How much work does the cycle do on the road? Okay, there is an important question mark it. So there is a cyclist whose wheels are in contact with the road. Why they are calling it a skidding stop is because once he starts applying the brake, this point is going to skid, means it is going to have only translatory motion. It does not rotate. The wheel will not rotate anymore. It will go in a straight line path. So when he is trying to go, there will be a frictional force of how much value acting? 200 Newton. Because if you read the question, there is one important point given. During this process, the force on the cycle due to the road is 200 Newton. So the only force the road exerts on the cycle is frictional force.
Friction.
So 200 Newton is going to act throughout a distance of how much value? 10 meter. Okay. So displacement is 10 meter. So what is the work done in the process of skidding? This is equal to what? See, I told you work done in the process of skidding, but what is the important question you're supposed to ask me? I told you yesterday.
Work done by what?
Work done by which force? Right? That's right. So here, how many forces are actually acting? See, observe the physics behind this. Road applies force on cycle and cycle tries to apply force on road. Will this happen? If you try to draw a free body diagram, the force that the wheel, the bottom of the wheel is experiencing due to the road is the kinetic friction in the opposite direction. I told you some important point about friction. What did I tell? It is an what pair?
Reaction pair.
It is called as an action reaction pair in the sense on the road there will be a frictional force acting in the rightward direction due to whom? So this is the force experienced by road due to cycle, whereas this one is force experienced by
Cycle due to road.
yes. So if this is taken as action, this will be the reaction, correct? So work done in the skidding process means my question point has to be more specific. Skidding work done by friction is how much? F into S into cos theta. I've taken it as I'm applying this formula because the frictional force given is a constant value. How did I find it's a constant value? Because it is independent of displacement, 200 Newton. So 200 into what is the displacement? 10 meter into cos of how much is the angle between them?
180 degree.
180.
That's right. So it will be minus 2000 joule. Whereas work done by cycle is how much? It is the same thing. Force into displacement into cos theta. What is the force acting on the object? Force exerted by the cycle on the road. I'm using a red color marker C. Is how much? It is still Fk. What is the value of Fk? 200. But the important question is this force that is exerted by the cycle able to move the road?
No,
Will the road start?
No,
So
sir.
the displacement here will be 0. So answer will be 0 joule. You're able to understand, though the magnitudes are the same 200 Newton, I hope you're able to visualize this point. If you're applying a force, if there is a displacement acting on the object, it is then you can define work done, or else there is no concept of work done at all. So I hope it is clear.
yes, sir.
Fourth one. A force of I cap plus 5j cap plus 7k cap acts on a particle and displaces it through a distance of 6i cap plus 9k cap. Calculate the work done if the force is in Newton and displacement is in meter. So it's very simple. Work done is equal to F vector dot S vector. Do it fast and tell me. You can directly do it in one step. Six.
Sir, voice is low, sir. I'm not able to hear.
Is it better now?
Sir, yes, sir. Okay, sir. No better, sir.
So work done is equal to F vector dot S vector. It will be 6 plus 63. Why did I get 6? Coefficient of I cap here is 1. Coefficient of I cap here is 6. Coefficient of K cap is 7. Here it is 9. 6 plus 63 is 69 joule. So the work done is going to be 69 joule. I hope it is clear.
Yes, sir.
Yes, sir.
So we'll do one last problem. There is a fifth one. And then we'll go to the variable force. Okay, now listen. So there is a force F vector is equal to, so solution given is what? F vector is equal to minus k into y I cap plus xj cap, where k is a positive constant, acts on a particle moving in the xy plane, starting from the origin. So let's visualize it, okay? Before we start solving, let's visualize. So you have the basic coordinate system. By the way the force is given, can you tell me in which quadrant? Is it moving in a 2-dimensional plane or a 3-dimensional space?
2-dimensional plane.
Because they told it is xy plane, they have given it, right? When this is happening, the object is starting from the origin. When the object is starting from the origin, the particle is taken along the positive x-axis to a point. It is taken to a positive x-axis to a point. How much? a comma 0, and then parallel to the y-axis to the point
A comma A.
a comma a, right? Yes. Calculate the total work done by the force on the particle. Okay. I will do this problem in two ways and show. You can follow either of the methods. I'm taking A, B, and C. So they are asking total work done. So total work done will be equal to work done from A to B plus work done from B to C. Accepted. So what is the work done by the force from A to B? That is F vector dot displacement vector from A to B. So what is F vector is? Minus K into yi cap plus xj cap dot. What is the displacement of AB? Displacement means it is the final. It is final minus initial. Tell me. A. So initial position is origin.
A minus 0.
A minus 0 I cap plus
0 minus 0 J cap.
yes. Now if you multiply both, you get minus K into Y into A. Accepted?
Yes, sir.
Yes, sir.
Similarly, what is the work done by the particle from B to C? Minus K into yi cap plus xj cap. Wait a minute, wait. So starting from the origin, the particle is taking on. So here, first of all, the object is not moving under constant force, right? See, now tell me one thing. See here, x and y stand for the x and the y coordinates. Here, y is there, x is there. No. But the particle has moved from A to B. What is the value of y and x I need to substitute at point B?
For y it should be 0 and for x it should be A.
Means which component will be 0? Y component should be 0. Means here, if you observe, to confuse you, what they have done is, for the y component, they have given x as the coefficient. Right? So what we can say is, from this we can imply that work done from A to B is equal to, wait. So I'm repeating it again, listen. Everyone listen carefully. So what I'm going to do is, I will write it as K minus K into yi cap. In the place of y, what will I write?
0.
Ai cap. Because I told you, no.
Okay, sir.
1 minute. See, actually, according to me, this should not be a constant force at all. It is a variable force. Wait. So I'll look into this problem and get back. Okay. So this has to be solved using integrals only. I just have a doubt of why I gave it under constant force. So we need to follow integration. So integral of I'll look into this problem and get back. Because I want to solve it using two methods. I'll explain it in the next class. Okay. So this is all about the constant force. Now let's solve some problems which are based on variable force. Okay. So for variable force, what is the formula that we are going to use? For variable force, what formula are we going to use? Work done is equal to integral of F vector, or we will write it as integral of F dx from R1 to R2. You can take it as dx or F ds. I think this is the formula I gave you, right? And one more important point, please make a note of it. If force displacement graph is given with force on y-axis and displacement on x-axis, okay, with force on y-axis and displacement on x-axis, then the area under the graph gives the value of work done. Make a note of it. If the force displacement graph is given with force on y-axis and displacement on x-axis, then the area under the graph gives the value of work done. Okay, so what I'm trying to say here is, if this is force vector, this is displacement vector, then if there is a curve like this, if you draw perpendiculars, then this area will give you the value of work done by the force. Okay, is this clear?
Yes, sir.
So we are going to use these concepts to solve the problem based on this exercise. So there is an object which moves from point A to B under the action of force varying magnitude as shown in the figure. Obtain the work done. Force is expressed in Newton and displacement in meter. Under the action of force as shown in the figure below. So this is the diagram. An object is starting from A, it is going to point B. We need to calculate the total work done. What are we supposed to do? Calculate the, just now I told you, if force is taken on y-axis and displacement is taken on x-axis, how do you calculate work done?
Area under it is work done.
Yeah, area under it. So you need to calculate this area. And remember, mathematically, when you're calculating the area with respect to graph, any area above x-axis is positive, any area below x-axis is negative. Make a note of it. Any area above x-axis is positive, any area below x-axis is negative. So tell me, what is the work done from point A to B? What shape does it take? From A to B, what shape does the graph take?
A linear one.
Yeah, linear is okay, but if you join it, you need to calculate the area. What shape is this?
A rectangular shape.
So for a rectangular shape, what is going to be the area? This
Length
height
into
is, yes. So it is 10 into, how much is this value?
2 minus
1.
2 like this. 10 joule, can I write it like this?
1. Yes, sir.
So I can write it as 10 into 1, that will be 10 joule. What about this area? That is work done from P to Q. What shape does it take? It takes the shape of a trapezium, right? So trapezium, what is going to be the area?
Half into sum of parallel sides into height.
Half into sum of the parallel sides into height. So
Height.
which are the parallel sides here?
Ten meter and 15. 10 Newton and 15 Newton.
Okay, then how much is the base?
1.
Yes, half into 1 into 10 plus 15. That will be 25 by 2. 25 by 2 joule. Similarly, you guys calculated for Q to R. Half into base into height. Height is how much? 15. It will be 15 by 2 joule. Similarly, what is the work done from R to B? Half into 1 into minus 15. So work done from R to B and work done from Q to R will get cancelled. So what will be the total work done?
10 plus 25 by 2 joules.
10 plus 12.5, that will be 22.5. Are you able to understand this?
Yes, sir.
Others?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah. Okay. Next. So the second one is a textbook question. It's an NCERT question. Mark it also as important. So which chapter are they teaching in school, by the way?
They are teaching this chapter only, sir.
Which concept are they teaching?
They are in energy for our class.
Okay. So a woman pushes a trunk on a railway platform which has a rough surface. She supplies a force of 100 Newton over a distance of 10 meter. So there is a constant force of observe the graph. No, there is a constant force of 100 Newton that is being applied for a distance of 10 meter. Thereafter, she gets progressively tired and her applied force reduces linearly with a distance of 50 meters. So her force is getting decreased to a distance of linearly with distance to 50 Newton. Means initially she applied 100 Newton, now she has dropped down to 50 Newton. That is what they're trying to say. Okay. Now what are they asking? The total distance by which the trunk has been moved is 20 meter. Plot the force applied by the woman and frictional force, which is 50 Newton. Calculate the work done by the two forces over 20 meter. So the total distance to which the trunk is moved is 20 meter. I hope you guys are able to understand this point. In 20 meter, there are a lot of changes that are happening. From B to C, it is a constant force. From C to E, it is a variable force. This 50 Newton. Calculate the work done by the two forces over 20 meters. So how to do this? Again, calculate the area. From C to E. So what is the work done from B to C? What shape does it take? What shape does it take?
Rectangular shape.
Rectangle.
So 10 into 100 will be 1000 joule. Similarly, what is the work done from C to E? It takes the shape of a trapezium. So what is the work done from C to E?
Half into 100 plus 50 into 10.
Half into, that's right. Half into 100 plus 50 into 10. So it will be 5. So 100 plus 50, 150 into 5 is 750, right? So you have a total work done as how much? So total work done is 1750 joule. Is there any doubt till this point? Did you understand?
No, sir.
No means you didn't understand or you have no doubts?
No doubt, sir.
No doubt. Okay. So this 1750 joule is a work done by whom? Work done by woman. Accepted? I'm
Yes,
sorry, I
sir.
don't have space to write. I'm writing it here and there. So work done by woman. But they have given an important point. They told it is moving on a rough surface. So when it is moving on a rough surface, there is friction that is going to be present, right? So what is the work done by friction, guys? So work done by friction will be equal to how much?
Minus 15 to 20.
Minus FK into S.
So that is 50 into 20. 50 into 20 with a negative sign. So how much is this?
Minus 1000 joule.
So minus 1000. So what they are asking is calculate the work done by two forces. No, one of the forces is by woman. So work done by woman is going to be 1750 and work done by friction is going to be minus 1000 joule. So what will be the effective work that be done by woman?
750 joules.
750. So is it clear? So wait, I'll try to shift myself. I think it is better, right? Now let's do the third problem. So the third problem says what? A particle moves along an x-axis from where to where? X is equal to 0 to x is equal to 5 meters under the influence of force given by 7 minus 2x plus 3x square. Find the work done with variable or constant force. So in the third case, are we dealing with variable or constant?
Variable force.
So what is the force that is given?
Variable force.
7 minus 2x plus 3x square. Find the work done in the process. So the object is moved from x is equal to 0 to x is equal to 5 meter. So work done will be equal to integral of f dx from where to where? 0 to 5. So integral of f is 7 minus 2x plus 3x square times dx between 0 to 5. So tell me how to integrate it. 7 into integral of dx between 0 to 5 minus 2 into integral of x dx between 0 to 5 plus 3 into integral of x square dx between 0 to 5. That will be 135 joule. So these are all the problems for today. We will go to the next concept. See, if you guys are not going to ask any question, there is nothing I can teach. So right on the next topic, that is energy.
Your voice is low, sir.
Sir, your voice.
So write down the next topic, that is energy. So energy is defined as the capacity to do work. So capacity to do work is what we call it as energy. Okay. Its unit is joule. It is still joule only, and it is also a scalar quantity. Next, the types of energy we can speak about. So what are the types of energy that you already know? You have potential energy, kinetic energy, then we have elastic potential energy, all those things, many other things too. Okay. So we will see what is potential energy. So what is potential energy? Energy possessed by an object by virtue of its position, shape, and configuration. Okay. So if there is an object which possesses potential energy, it is possessed due to whom? Possessed due to the position, shape, and configuration of the object. Similarly, what is kinetic energy? See, people know the answer for this, right? So it is energy possessed by an object by virtue of its motion. So if this kind of a scenario arises, we call it as kinetic energy. Okay, so this is potential potential energy, this is kinetic energy. Now, write down the heading as gravitational potential energy. So you have an object, okay. Let's say you have an object of mass m, which is projected upwards with a velocity u. Now, what will happen to this object is it is going to reach a maximum height where its velocity is going to be 0. Right? The important question that we need to answer is, what is energy possessed by this object when its distance is changing? So what exactly will happen? Can someone explain what is the physics behind this?
Sir,
Sorry? There will be weight of the object acting in the downward direction, that is mg, and the object is getting displaced in the upward direction, let's say by height h. Accepted? Yes or no? So if I ask you a question, what is the work done by weight of the object through a distance h? So work done by weight of the object through a distance h. What is it?
mg into h.
So W is equal to mg force. So we know the formula, force into displacement into cos theta. Here we are dealing with constant force because mass of the object is constant, g is also constant. With acceleration due to gravity. Mg into h into cos of, how much is the angle between both? What is the angle between mg and h?
180.
Yes, it is 180. Cos 180 is minus 1, so it will be minus mgh. Have you ever seen this formula? You have already seen this, right? What is the name of this? You would have applied many times. So this is going to be the formula for gravitational potential energy. Okay, so you have seen this, right? mgh is the formula that is for gravitational potential energy, and here negative sign indicates object is moving against the force. See, if you guys don't respond, I'm not able to teach, to be very honest. If you're not going to respond, let's wind up the session. I don't want to continue.
Sir, can I scroll up, sir?
I'll do that. But I want some response, okay? I can't teach. It's like I'm speaking to myself. Instead, I would record the session and give it to you guys. You can study whenever you want. What is the use of having this live session? I'm telling that this is a very, very important concept. I'm not sure if you guys are able to understand or not.
Understood, sir.
Only you're responding. Others, what about others?
Understood, sir.
There is only one student.
Understood.
Actually, sir, I have a small doubt.
Understood.
What is
In potential energy.
Yeah, please.
Sir, what does configuration means in potential energy?
Configuration means, yes, so these are the questions you need to ask. So what do you mean by configuration? See, I'll take a simple example. We know that every object in this world is made up of atoms, right? So
Yes,
you would
sir.
have heard about the distances, intermolecular distances, right?
Yes, sir.
So when
Yes,
this
sir.
intermolecular distances concept is coming, there is a concept called as potential energy that is existing between the atoms. It is happening because of the charges that are present in the system. Okay. Suppose I give you a pen. Okay, let's take a simpler example. If I give you a paper, okay, when I give you the paper, it is going to be in the rectangular shape. When it is going to be in the rectangular shape, I'm talking about shape. I hope the concept of shape is covered. Yes, you're able to understand that?
Yes,
So
sir.
this paper has some energy associated with it. So why is it having energy associated with it? Is because it is made up of atoms, and let's say the atoms are separated by a fixed distance. Because it is going to have a regular shape, I'm assuming that the atoms are separated by fixed distance, and the atoms interact among themselves in the form of intermolecular forces and attractions. Okay. So wherever the charges are able to interact, there will be some energy. About that, you will learn next year. So when the paper which I gave you, when it is in the shape of rectangle, the intermolecular forces between these two charges depends on the distance of separation between them. So here I'm trying to say, let's say they are separated by distance r. The energy is going to have a value because of this r. Now, what will happen if you crush this paper?
Distance would reduce.
Your shape is going to change, as a result of which you're trying to change the distance also. Means you're actually changing the configuration of the system. At that time, what will happen is that paper which is crushed might have a greater energy compared to this one.
Okay, sir. So
Okay.
can we say
So,
shape and configuration are related?
yeah, they are. See, here I took the example of both shape and configuration. See, there might be a scenario. See, I can take this example. For example, instead of charges, no, in your 9th standard, you would have learned universal law of gravitation, right? When two
Yes,
masses are
sir.
separated by a distance r, then there exists a force between them. F is equal to how much? G m1 m2 divided by r square. You would have seen this formula, right? So in this thing, you would have not learned one point, that this system also has potential energy associated with it. And the potential energy is happening because the configuration, because here you cannot talk about shape. The two masses are separated. But here the configuration you have given is, configuration means the way you have arranged is in such a way that M1 and M2 are present in the space which are separated by distance r.
Okay, sir.
Okay. So to put it very simple, configuration means the way we have arranged the particles in the system. Okay, that plays an
Okay,
important
sir.
role. Okay.
Understood, sir.
So that is what you mean by configuration. So here the concept of configuration doesn't come for gravitational potential energy. It is only going to be the distance. The position of the object is going to define its potential energy. So here, what is the important point I wanted to say is, we are talking about potential energy, but what is that we have calculated on the left hand side?
Work.
We have actually got the expression of mgh because of work done. But I'm calling that mgh as energy. Why am I not calling it as work done by the gravitational force? Because what does the definition of energy tell us?
It's a capacity
Energy,
to do.
it is the capacity to do work. The meaning of this is, in this whole world, whatever work you're trying to do will get converted into some form of energy. That is the meaning. If there is a force and the force is able to cause some displacement, then every force that is causing a displacement will do some work. By doing that work, it will create some form of energy. That is what you would have learned in your 9th grade again. Energy can neither be created nor be destroyed, but it can be converted from one form to another. That's where the concept of energy conservation starts. Means whatever work you do will get converted to some form of energy. Here, who is doing the work? The gravitational force is doing the work, right? And the work done by the gravitational force is getting converted to equivalent amount of energy named as gravitational potential energy. So from this, one important point to be kept in your mind is throughout physics or throughout science, okay, wherever you see the word energy in your back end, you should run that. For calculating the energy, the only way is by calculating the work done. Am I clear about this?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Now see. So
Yes,
here
sir.
we got the gravitational potential energy. Now let's see what is kinetic energy. I hope you guys made a note of it, right? Let's see what is kinetic energy. Now I will take a simple scenario. Let's say there is an object which is given an initial velocity u and it has traveled a distance s where it has got final velocity v, and let us assume it has traveled with uniform acceleration. Then v square minus u square, can I write it as 2as?
Yes, sir.
So multiply with mass on both sides. What will happen? mv square minus mu square will be equal to 2 times ma into s. So this 2, if I take it to the other side, it will be half mv square minus half mu square is equal to m into a into s. What is m into a? It is f. S is displacement. This will be equal to half mv square minus half mu square. Force into displacement is what?
Sir,
Work. Yeah.
could you explain from first for kinetic energy? My internet connection was unstable.
I'm explaining. I'm saying that there is an object which is having initial velocity u and final velocity v. It is moving with constant acceleration a and the displacement is s. Then v square minus u square is equal to 2as. I multiplied with mass on both the sides. mv square minus mu square is 2 times ma into s. Bring the 2 to the left hand side. Half mv square minus half mu square is ma into s. Ma is nothing but force. S is s only. So force into displacement is what is called as work done. Then what is this thing called as? This is what is called as change in kinetic energy. It is actually not kinetic energy. It is called change in kinetic energy because if you are able to define the product of half into mass into velocity square, then that particular parameter is what is called as kinetic energy. Because you never ask the question like, why are we defining kinetic energy as only half mv square? Why can't it be 1 by 3 mv square? Why can't it be only mv square? We don't know, right? So what actually has happened is, when you're doing this kind of a rearrangement, it was observed that there was a physical quantity which is termed as half mv square that is coming into picture. If you are able to define a parameter half mv square, then that half mv square is what is called as kinetic energy, and half mv square minus half mu square is called as the change in kinetic energy, and this is going to be the amount of work done. You're able to understand how the derivation of kinetic energy has actually come.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So this work done is equal to change in kinetic energy is what is called as work energy theorem. Okay. So you need to have this in your mind. Write down this derivation.
Sir, could you go a bit up?
This is okay.
Done, sir.
So this is all about potential energy and kinetic energy. Okay. So this will stop. Just wait for a minute. Don't leave.